Thank you for introduction. First of all, I would like to thank the organizers for inviting this celebrating conference. It is very my great pleasure to talk here. Thank you. And today I talk about local new forms for unramified auto-unitary groups. This is a joint work with Masao Oi in Kyoto University and Seida Yasuda in Hokkaido University. Okay. Okay. First I explain an introduction. So maybe okay. First, I am interested in theorem of correspondence between modular forms and automorphic representation. For GL2 case, there exists a canonical bijection between eigenform F in cusp form of cuspidal new form holomorphic weight K and level gamma 1n up to non-zero constant. To the set of reducible cuspidal automorphic representation by of GL2 attained such that the infinite part is, of course, a discrete series of weight K, and the finite part is a level exactly up to isomorphism. The injectivity is developed by Atokin, Lehner, and Lee. Injectivity is so-called multiplicity one result in new form. This is theory of new forms. Developed by Atokin. 72 and D 75. On the other hand, surjectivity what is surjectivity? For proving surjectivity, you have to get a good vector from infinite dimensional representation. So, because pi is a tensor product of local representations, we have to get a good vectors for each representation. This is given by local new forms. Local new forms of GL2 QP. This is by Kastelman, 73. So to generalize such phenomena for higher degree modular forms, we need want to establish, generalize, or the theory of local new form. えーっと、for other groups. And there are several known results. Known is first of all, general linear group case is developed by maybe I cannot write down. This is Jacques-Piatteschi Shapiro Schreiber. Schreiber. 1981 and PG, okay, next page. I'm very sorry. And PGSP4 and double cover of SL2 is developed by Robert Schmidt, Roberts and Schmidt. Uh, 2007 and 11. 2007 and 2011. Others are U11, U21, and SO2N plus 1. U11 is Lansky diagram. Zero 4. Miyauchi. 13 to 18. And for SO2N plus 1, this is only a super capital case. This is proven by Tsai. 2013. So today, I want to explain the case of UN plus 1 comma n. Okay, so next, let me explain the main theorems. Local. So what is local new form? So first, I fix notation. E is a finite extension of a periodic field. Finite extension. Maybe as you know, OE is a ring of integer. And PE is a maximal idea of OE. In my talk, I only consider matrices of size odd. So big N is an odd number, and G is GLNE, and like K0 is a maximal compact open subgroup, standard one, GLNOE. So for positive n, set Km is defined by such matrix to divide by N1N, N1N, OE, OE, to PE minus M, PEM, 1 plus PEM, OE, to PEM, PEM, and OE. And intersect of determinant is unit of ring of integer. Okay, this is my group. Then the famous result of Jackie P.S. Schleicher is as follows. That's it. Theorem by Jackie P.S. Schleicher. When pi is irreducible representation of G, which is generic. Generic means pi atom is a Whittaker model, and then let me write C pi. This is a minimal non-negative integer such that the fixed part of Km, the subspace of vectors fixed by Km, this is a non-zero space. First statement, this is actually finite and called conductor of pi. And what's the important is the dimension of the first non-zero space of this type is dimension 1. No. Good. A non-zero element of this one-dimensional space is called local new form. Non-zero element in this one-dimensional space K C pi is local new form of pi. So today I generalize this theorem to unitary group case.
They have organized the year somewhat differently.
Yeah.
By looking at the evolution.
Yes. Yes, for unitary group test, I use this. So, to explain unitary case, I need more notation. So first, take a quadratic extension, unramified quadratic extension, unramified quadratic extension of periodic field of periodic field. But in my talk, after in the rest of my talk, P is assumed to be odd, not 2. So G, K0 and Km is the same, GLE, K0, K1, as above. The same, but H is a unitary group, which is defined by the subgroup with theta fixed elements. What is theta? Theta of G is essentially this is transpose G by inverse, but this is not good. So take conjugate by 1 minus 1, last is 1. 1 minus 1. Then we can define a compact open subgroup KMH by just taking intersection of KM and H. Now I can state my main result. Okay. By myself and Oi-san and Yasuda-san. Today I will consider a tempered representation. Tempered representation of unitary group H. First, if pi admits a KMH fixed vector for some H, for some M, then pi automatically generic. Pi is generic. So pi admits a Whittaker module. Then how about the generic case? So second, suppose pi is generic. We need more notation. Let phi is L parameter of pi, which gives a conductor C phi maybe I explain later. Conductor of the phi. And then in this notation, dimension of pi kmh fixed vectors are 0 if m is less than conductor, exactly 1 if m is exactly equal to the conductor, and finally positive if m is bigger than conductor. This is our result. After putting our paper on archive, Yao Chen compute this dimension expressed to theorem by Chen. If pi is irreducible generic representation, size 2n plus 1, generic, then this dimension is given by binomial coefficient of half of m minus conductor plus n choose n for m. Okay. The local Lagrange correspondence. So, this is regarded as a representation of Bernoulli group of E to GLNC. Yes. I mean, as usual, L parameter of pi is L homomorphism from Bernoulli group of F to the L group of yes. And by restricting to Bernoulli group E, we can get a conjugate conjugate symplectic representation of Bernoulli group. Conductor is the conductor of corresponding representation of GL and E. So phi gives a representation of GL and of E, and we can define. Okay. Okay. And here. Okay, first explain a proof of the first statement. proof of maybe I want to write. This is theorem A. So
AK minus right?
AK minus
Was nothing of this kind was known before.
yes. But I want to write one more main theorem. Proof of theorem A first. Here I didn't work hard, but just I use hard works. So the starting point is the non-zero fixed vectors, and the goal is the goal is Paris generic. The important point is to get a middle statement. Middle statement is there is a sigma is a tempered representation of U to N, which is unramified. Unramifiedness is the most important, such that Hom space of U to pi tensor sigma to C is non-zero. Actually, this condition is equivalent to generic. This is by local Gunn-Gross clustered conjecture. This is proven by Busar process. To 2016. Okay. And then the final step is show here, but this is just Gunn-Sabin's lemma. And we can we have done. Okay, so I move the main step, the second part. Okay, the second part proof of second part. For in many previous result, usual strategy is apply integral. But this has a disadvantage. This is this huge computation for H algebras. Huge computations. So, in our paper, we don't use this strategy, and instead of this, we prove an analog of fundamental lemma. So, our strategy is analog of fundamental lemma. So, what's mean? The second main theorem is as follows. Myself and Oi-san and Yasuda-san. Statement is volume of KMH inverse times characteristic function of KMH. This is a function of H is transfer of volume of Km inverse times characteristic function of Km times theta. This is a function of G times theta. But I'm sorry, but yes. G is GLNE and H is a unitary group. G theta. Sorry, but I couldn't explain what is transfer. But anyway, there is a good relation called transfer, and these two functions are transferred. Similar results are known. There are many similar results, but and many results, so I cannot list all of them. But important case is first of all hyperspecial case. This is so-called fundamental lemma. It's due to Go Bao in 2010 after hard work of the various pressure. あるかな。2006から2008。reductive groups. This is due to by Katsan Balsharsky. 2012, and also principal congruence subgroup is due to by Ferrari for standard endoscopy and by Galapagos-Barber for twisted endoscopy. Okay. So now I explain how to use this theorem P. Theorem P to theorem A. So recall pi is an irreducible tempered representation of H, which is generic. And phi is an L parameter of pi. Phi gives two ingredients by local Lagrange correspondence established by Mock. The first is by phi, which is irreducible tempered representation of GLNE, which is G. I wrote such that it is a conjugate self-dual and conductor of phi is exactly a conductor of pi phi. And the other is so-called L packet. This is a finite subset of irreducible tempered representations, the L packets. Finite subset. LC has many properties, but we use two properties such that the first property is so-called uniqueness of a generic member, namely in this packet, generic member is exactly equal to a singleton set pi. So original pi is contained in this our L packet, and no other member is generic. And also, a most important property is called endoscopic character relation. Endoscopic character relation is theta of pi phi theta fg is equal to theta normal sum of pi prime in packet theta of pi fh. For fg is a function on G cross theta. But Fh is a function of H. The relation is this is transferred. And here, theta pi is a character of pi, a Harris-Chandra character. And phi theta is a twisted version. Twisted analog, twisted character. Okay, so I have now expressed transfer, so I can use this equation. So first, let me start the sum of packet of theta pi prime volume k mh inverse 1 of kmh. Let us compute this. By definition of character, this value is exactly equal to the dimension of k prime kmh fixed vectors in pi prime. But except for original pi, pi prime are not generic. And the non-generic case, this dimension is 0. So this is exactly equal to original dimension. What I want to compute. On the other hand, the twisted character of volume km inverse times characteristic function of km cross theta is not dimension itself, but a certain trace of involution on km fixed vector in pi phi, and this is an involution. This involution is mysterious, but we know this space very well. So, by GPSS plus result of leader, this space is 0 if M is less than conductor. So because space is 0, trace is also 0. If M is exactly equal to conductor. This space is one dimension. But I is involution. So involution of trace of involution of one dimension space is plus one or minus one. And if conductor plus one by leader, dimension of this space is 2n plus 1, the size of matrices. This is assumed to be odd. Trace of involution odd dimensional space is non-zero. By 7b, our dimension is equal to this guys. But important is dimension is non-zero, non-negative. So by 7b dimension is the first case is of course 0, but the second case, the main case is dimension is plus 1 or minus 1, but the dimension is non-negative, so plus 1. And the third case, non-zero and non-negative, so this is positive. G5 plus 1. And this gives the second part. Maybe one more. Okay. Okay, m plus 2h is a conjugate of k m plus 2h is contained in kmh, so this is bigger than kmh. So theorem A2 is proved. I have 10 minutes. Okay. So finally, I explain what our argument of 7b. Section 5. Three steps. Yes, right. But in our case, just a unitary group case, so a very easy case. Step 1, not easy for me, but maybe. To reduce so-called descent by descent, so we can reduce 7b to comparison of certain conjugacy classes. Of so-called topologically semi-conjugacy class. Simple G times theta and H. I mean, for a little precision, for certain data, gamma, there exists, we can define a subset of km times theta modulo km conjugacy. Tilde sub something means conjugacy by this group. And B is kmh over kmh conjugacy, such that to prove theorem B, it is enough to prove that there is a canonical bijection between A and B. Bijective canonically something.